Everyone, today we are going to go through the mind map or concept map for Unit 8 Magnets. Thank you to Chikuazima for making this beautiful concept map for us to try. And so let's go through the answers together. Okay, so magnets, they have two poles, which is called the North Pole and the South Pole. Magnets come to rest in the north-south direction when it is suspended. When unlike poles are facing each other, there is attraction going on. So the south and the north will actually get attracted to each other. And when like poles are facing each other, we get repulsion or repelling. So the north and the north will actually push each other, and the south and the south will also push each other. So whenever we have this push or pull, then that means that there is a force, and we call that the magnetic force. Magnetic materials are materials that can be attracted to the magnet, and usually these are metals, but not all metals are magnetic. Only these four metals are. So they are nickel, you have iron, cobalt, and also steel. These things, so magnets actually. So magnetic materials, you have these metals, right? Nickel, iron, cobalt, and steel. And these four can actually be turned into magnets as well. And magnets are mainly used in compasses, ATM cards, this one right here is a door stopper. I think this is for electric motors, maybe. And also in separating magnetic materials from non-magnetic material. So what you see over here is a classic example of an experiment where they separate magnetic materials and non-magnetic material. This yellow thing right here, this is sulfur, which is a non-metal, and all non-metals are non-magnetic. And this one right here is a magnet, and it's actually, so the sulfur is mixed with that like metal looking shiny thing, and that's iron filings, I think that's how you pronounce it. And so when they're mixed together, how can you separate it? Is you use a magnet. So that's one of the main uses of a magnet. And this is a mixture because they're not chemically combined together, so it's easily separated. Okay, last one, 7, is, remember I told you about the push and the pull, so magnetic forces. And magnetic forces, you can actually show them in these line drawings. So for all the north, so north is always going outwards. So you can see here the arrows are going out, and the north is always trying to go to the south. So you can see here coming here like that, and north to south as well. And then for the south direction, you can see that the lines, the force here, magnetic forces, are going inside. So the lines of force. So how do you draw that? Like if you have a north and the south, so opposite poles together, you can draw a straight line here, arrow from the north to the south always, and don't let them touch. Like, make sure that they are social distancing. And then over here, get that one out. And then if it's like too far, so this is gonna break a bit, but north is going outwards and the south is always going inwards, like that. So this is attraction and this is repulsion. So why is it pushing away? Is because you can see here the forces, like the lines of forces, are pushing up, so they're not going to meet because they are social distancing, so they are pushing each other away. Okay, so I think that covers non-magnetic materials. We didn't do that part. So we talked about magnetic materials, which is nickel, iron, cobalt, and steel, which are all metals. And examples of non-magnetic materials, you have rubber, wood, you can have plastic, and you actually have metals that are non-magnetic, for example, copper, and also aluminium. Okay, so I guess that's it for everything, yeah? We're gonna go check out the past paper questions. We're gonna do pages 1 to 4. Don't forget to write down your name, your class, and the date. So this is the SPE compiled questions from the SBC Brunei. So thank you to the Science-Based Committee and Brunei teachers for helping us practice past paper questions. Alright, so topic 8.1, magnets and non-magnetic materials. Like poles of magnets will attract each other. Like poles, that is false. Like poles would repel. Nickel and cobalt are examples of magnetic materials, that is true. Magnets will attract cobalt and iron. That is also true. Complete the following passage by using the helping words provided. You may use the words once, so only once, more than once, or none at all. Magnet is a piece of solid with special properties. It can be used for many purposes. Junkyards use very strong magnets to separate. So it says here iron. So iron is a magnetic material. Such as iron, and is there any other one here that's magnetic? Yes, steel. Materials such as glass, aluminium, and copper are known as non-magnetic. Magnets are also used in motors and electrical appliances such as fans, food blenders, and toy cars. The magnets in the motors help to convert electrical energy into something. Kinetic energy. Because there's movement energy, so we don't call it movement energy anymore, we call it kinetic energy. If the north pole of a magnet is brought very near to the end of an iron bar, the end of the iron bar and bar magnet will do something. So we have iron and a magnet, and so it's actually going to attract each other. A bar magnet is broken into 3 parts, X, Y, and Z. Which diagram shows the poles in X, Y, and Z? So here you have the north pole and that's the south pole. So Y is here. So what should this be? So I would assume, because it's actually broken up already, right? This is the north pole on one side and that's the south pole on one side. I would think this should be the north and then this should be the south. But let me have a check in this one actually. What happens? Let's have a Google of that. What happens if you break a magnet in half? Oh, the newly cut faces will become the north or south poles of these smaller pieces. So that's what I would assume as well, actually. So here, oh, so both parts would actually have a north and south pole. So actually, so when you break it up, that one will be the north and that will be the south. Okay, I think this one's a better picture, but let me just... Okay, I can't really show that to you. Okay, there you go. This one. This is a good photo right here. So it actually shows you there. Maybe we can make it bigger like that. Oops. Yeah, so if you break it into pieces, then north here, and so the middle will become, that end will become the south, and then that will become the north, and that will be the south. So I'm actually wrong here. It's a good thing I went to ask Google, but yeah. Alright, so this will become the south, and then this will become the north, and then south, and then north and south. I think because like it would be like attracted to each other, right? I don't know. I guess that's what it does. So let's see which one looks like that. North, south, north. And wait, no. North, north, south, north. North, south, north, south, north, south. Okay, I think it's D. Definitely D. Siti Aniza found 2 bar magnets with no labels on them. She did 3 experiments as shown by the figure below. The arrow shows the movement of magnets, which experiment shows 2 unlike poles next to each other. Unlike poles, that means that it's gonna be attracted to each other. These ones seems like they're repelling, and that's repelling as well, and this looks like it's attracted to each other. So I would say unlike poles would attract, so I would say just C. Experiment 3. So that is page 1, 2. Okay, so now we're moving on to page 3. Sharifa placed 2 bar magnets 4 times next to each other. The movements of the magnets are shown in the figure below. What could be concluded by Sharifa from her observations? So you can see here north and north poles next to each other, and they are repelling. South and south poles as well repelling. And you have north and south poles attracting, and north and south poles attracting. So this is the part about, I think it's something to do with like how magnets work. So like poles attract each other? Nope. Like poles repel each other? Yes. Unlike poles attract. That's correct. So it's B. Aminuddin placed 3 toy cars X, Y, and Z at these positions. He put a bar magnet inside each car toy as shown in the figure below. What would happen if Aminuddin pushed all toy cars together as shown in the figure? Okay, so you have south and south going together, north and north, so it's definitely going to repel each other. So toy X and Y should repel. Toy X would repel toy car Y. These 2 are correct, and Y and Z also would repel. So the answer is D. Alright, last page for today. Which of the following pairs consist of magnetic materials? So you need to remember your metals. Aluminium is non-magnetic, steel is, gold ring is not, silver is not. Iron, paperclip, yes. Copper, no. Iron, yes. Steel, yes. So D is the answer. Iron has 3 unidentified rods, X, Y, and Z. The rods can either be magnet, copper, or iron. To confirm their identity, he placed a bar magnet near one of the ends, X, Y, and Z, below. Which of the following is the correct conclusion made by Harun? So it seems like here, so the experiment, you have the North Pole, this rod X. And then so it attracts and it attracts. So I think rod X should be a copper or iron. Okay, so rod Y seems like there's a repelling, so that could be a magnet. Rod C, nothing happens. Oh, sorry. Copper actually is non-magnetic, so iron. And nothing happens, so that's a non-magnetic material, so that's copper. So X is iron, Y is a magnet, and Z is copper. X is iron, Y is magnet, and Z is copper. The answer is C. So we're done with that, and I'll see you guys next time. Thank you for watching. Have